So for this problem, we got the equation y equals 4 plus the square root of x minus 5. Now, what I really want out of the square root is the radicand, the inside of the square root there, to be some kind of perfect square, okay? Now, we know also that that square root that we have, which is the square root of x minus 5. So I'm going to write that up here in the top right, square root of x minus 5, that the x value, or the radicand, let's start with that. So the x minus 5, the inside of the square root, it has to be greater than or equal to 0, like this. And this is just an inequality that we can then solve, right? We can say, well, I can add 5 to both sides, and which will zero that out. I can drop my x. So x has to be greater than or equal to 5. But 5 is an important point, because if x were less than 5, then we'd get a false. It's not necessarily false. It's just a not real solution from that square root. Now that also means that in that square root, if I were to replace x with 5, then I should get a 0 from that square root. So the reason why that's important is because I can take that ordered pair. If I replace x with 5, then I should at least get a 0 in that square root. Let's just double check. So I'm going to take the equation and I'm going to drop it here. But instead of showing it as x, I'm now going to make it the 5 that I've kind of chosen, which again, if we've done this correct, it should make that radicand, the inside of that square root, it should make it a 0. So let's go and work with that then. So after just combining those two, I'd have 5 minus 5, which is 0, which is what we expected, right? So now we got y equals 4 plus the square root of 0, and the square root of 0 is 0. And so now we've got y equals 4 plus 0, and even at this point, I'm going to take that plus 0. I'm just going to make it a phantom 0. So that tells me right there, just from that equation that I have now, that the other value is 4. And this should be the smallest value on, for the domain, it should be the starting value, which means that this ordered pair 5, 4, which I'm going to put here, 5, 4, that is the kind of the starting point for our graph. So again, that's at 5, 4. I'll mark it. Okay, now what I want next is for the inside of the absolute value, inside of the square root there, to give me some kind of perfect square. Okay, now we've already used 0. For me, the next one would be 1. Okay, so how do you? And again, we're just focused on the inside of that absolute value of the square root. If I wanted to make that just its final value of 1, so here's what I mean by that. Is what I want is to, whenever I combine these two values, I want it to show the square root of 1. So something minus 5 needs to equal 1, right? Well, that value is going to be 6. So I know 6 minus 5 would give me that square root of 1, which would then give me this equation, y equals 4 plus the square root of 1. Now, before I proceed, let's just think about what this means. It's an ordered pair. We just chose a value of x that is 6, and we need to find its corresponding y value. So at this point, I say y equals 4 plus the square root of 1 is it's actually just 1. And then I know 4 plus 1 is 5. So I end with y equals 5. The corresponding y value with the 6 there is 5. So I can put that ordered pair on the graph. 6, 5, boom, it's right here. Now that it's right next to each other, there's my label. Here's what we don't want. So you get 2 points on the graph. They're pretty close to each other, and then students sometimes on tests, they may draw something like this, but you shouldn't draw that. And the reason why, just like we explained before, the domain starts at 5. Okay, so we're looking at x value 5. All x values to the left of this are not real numbers, so we can't put those on the graph. Okay, I'm going to do one more value here. Okay, so 2 should be good, but the other reason why we don't want that straight line is because it's not straight. As soon as we see a square root, symbol in an equation, we know that we're not going to end with a straight line. So what I want next is when I take the x and subtract 5, I want it to equal the next perfect square, which is 4. And we know that the square root of 4 is 2, right? So what value? So that x right there, I'm going to take it and I'm going to replace it with some value so that when I subtract 5, I get 4, right? Well, that would make the x value 9. So again, in the ordered pair, I've just chosen the next value that's 9. Really, it came with some analysis, right? So we're doing this with some purpose, which we've talked about before. We want there to be purpose, and now the equation shows y equals 4 plus the square root of 4. Now it's 4 plus 2, and that would equal 6 total. Okay, so that's a ordered pair of 9, 6. And this ordered pair, once we get this on, so that'd be at, let's see, 9, 5, 6 right here, okay? And you can see right here that the line is curving, right? So I'm going to see if I can do this, make this curve pretty. There it is. And that would be the line. But again, it's important for you to remember on these square root type problems that it starts here at where the x is 5, we found the corresponding y value, and then we chose these other two values of x as 6 and 9, but we did it carefully with purpose. And that's the key point. If we can do this with purpose, hopefully things will make more sense. And as we see this graph, we won't do something that's going to make us lose points, like just draw a straight line like this, or even make it go all the way through. We don't want that. It starts here, and then it curves pretty much into like a flat line right there.